Hey everybody, the purpose of this video is to give us some solutions for 2.13.22d in the Collaborative Statistics textbook. So what we have here is we have a revisit of an old problem. Erica and Javier, I believe. Yeah, Erica and Javier, Ursula and Javier. And they collected some data on something. Actually, it's not important. But there are the measures of center and spread that they got. So this is tied back to center and spread. That's why I kind of like revisiting it. They both got an average of 6, but Javier had less of a variability than Erica did. This question is, here's 2 box plots. Which one of them has to be Ercia's compared to Javier's? Okay, so actually it doesn't say that. It says which one has to be Ercia's and how do you know? So please excuse the way I've drawn them. I put 2 up here and 1 down here. Not that that matters. I wanted to draw them on top of each other like that because the way they are in the book, if you don't pay attention to the scaling, you might miss the fact that they are very, very different. In the book, they have the exact same width on the page. They're about like that. But in reality, as you can see behind me, they're actually very, very, very different as far as length or width, I guess. So looking at them, they both have a median around 6, which would imply they both have an average around, then the average being 6 and the median being 6. The green one up here is roughly symmetric. This guy is less symmetric. It's got some skew pulling to the right side, which means the average might actually, theoretically could be pulled to the right, but seeing that the average is 6 and the median is both 6, I guess that average isn't being pulled as much. There aren't any outliers, just large data values. The question is, which one has to be Ercia's? And the only number we can really look at is that standard deviation of 7. That's the only thing that can give us an indicator. Now clearly, a standard deviation of 7 is larger than 4. If we had to pick which one of these was Javier's and which one was Ercia's, this would have to be Javier, this would have to be Ercia, because this one's less variable than this one. Okay, but that's not what it says. It says which one has to be Ercia's. So it doesn't mean that the other one has to be anything. So let's look at number 2 for a second, this guy up here. Could that be Ercia's box plot for her data? Well, it looks like the largest data value is 12. The smallest data value is 0. The median is 6. The quartiles are about a 3 and about a 9. So they're basically uniformly distributed. They're basically uniformly distributed across. Let's think about that. If the average is 6, and the data values are uniformly distributed across, I'm going to make this as kind of extreme as I can and realize that making this as extreme as I can, we'll come back to that. Suppose these data values are a bunch of 0s, a bunch of 3s. Well, we can't do that. A bunch of 1.5s, a bunch of 4.5s, a bunch of 7.5s, and a bunch of 10.5s. So we're doing that, kind of plug the data into the halfway points. If you do that, you realize that you've got a bunch of data points that are 4.5 units away from the mean. A bunch of data points that are 4.5 units away from the mean. A bunch of data points that are 1.5 units away from the mean, and a bunch of data points that are 1.5 units. So if you think about that, the distances of the data points from the average are either 4.5 or 1.5. If you average a bunch of 4.5s and a bunch of 1.5s, could you ever get 7? And the answer is no. In order to get an average of 7, you have to have either all 7s, or you have to have numbers below 7 that balance numbers above 7. So I do believe it could be Javi's box plot. I think that's true. It could be Javier's box plot. I just don't think it could possibly be Ercia's based on that. Looking at the bottom one, using the same kind of logic, here we got a bunch of halves, sure. Here we got a bunch of 3s. Here we got a bunch of, what would that be, 9 apart. We got a bunch of 10s. Here we got a bunch of 18s. 18 to 6 is a distance of 12. 10 to 6 is a distance of 4. 3 to 6 is a distance of 3. 1/2 to 6 is a distance of 5.5. Those numbers can be averaged to find a 7, can't they? They could be averaged to find a 7. Because some are above and some are below. And since some are above and some are below, I believe that with the correct actual distribution of data, realistically, that could actually be a standard deviation that is in the 7 range, where the other one could not. So my vote, here's Erica's data right here. But the big idea was, as soon as you look at it the first time, As soon as you look at it the first time, you realize it's the more variable of the two. Now remember, it didn't say which one is Javi's, which one is Ercilia. I keep calling her Erica. Ercia's. Which one is Ercia's, which one is Javi's. It says which one could be Ercia's. I think we proved this one could not be, which means that one could be. Hope that helped.